بسم الله الرحمن الرحيم. ويسألونك عن الروح قل الروح من أمر ربي وما أوتيتم من العلم إلا قليلا. Good afternoon. I am Khalid Al-Afandi, PhD student in National School of Applied Science in Tetuan at Malik Saad University. Now I will present my accepted paper in this conference with title A Survey of Using Machine Learning Techniques for Classifying Remote Sensing Images. Let's start. We start our presentation with agenda. The agenda for this presentation contains introduction, remote sensing and remote sensing images, reviewed algorithms in this paper, the accuracy assessment and the comparative topics, results, and finally, the conclusions. Introduction. Now we start our introduction with the machine learning. What is machine learning? Machine learning is a branch of artificial intelligence that relies on training computers using real data, which results in computers that will have good estimations as a human experts for the same type of data. That means it's a process of importing dataset features and exporting out class for classifiers learning models or results for regressions learning models. That's depending on the used machine learning algorithm type. So there are some definitions that some definition will appear to the machine learning. The first definition is defined by Arthur Samuel. Arthur Samuel in 1959 defined the machine learning as the field of study that gives computers the ability to learn without being explicitly programmed. But Tom Michael in 1998 defined the machine learning as a computer program is said to learn from experience E with respect to some task T and some performance measure P. The aim of this paper. The first aim of this paper is illustrating the most famous used machine learning algorithm that used in classifying remote sensing images using pixel-based image classification and object-based image classification. The second aim is present a comparative study between the SVM and the ANNs and the pixel-based image classification and object-based image classification. Now we talk about a brief idea for remote sensing and remote sensing images. What's remote sensing and how can it done? And what's remote sensing image and what's its structure and what's the difference between the remote sensing image structure and digital image structure? Remote sensing. Remote sensing is a science of collecting the Earth's surface data without literally connecting with it. It's the action of measuring the reflected and the emitted radiations from a determined Earth surface area for screening and tracking the natural characteristics for this determined area. Satellites and aircrafts are the most suitable for this process. Remote sensing images. The remote sensing image is one of the special data sources for simple maps that show topography, land ownership, roads, and similar. These image sources are satellites and aircrafts. Remote sensing process. As shown in this figure, the remote sensing process can be carried out in 7 steps. First, the emission of electromagnetic radiation. The sun is the main source for this emission, and it can be assisted by some microwaves that emitted from the satellites. The second step is the energy transfer from the source to the Earth's surface. Through this transfer journey, the absorption and scatting can be done for these emissions. Third, the interaction of the electromagnetic radiations with the Earth's surface. It can be reflected or absorbed. Fourth step transmit the energy from the surface to the remote sensors. Fifth step, the remote sensors on the satellite send the data to the reception station on the ground. Sixth step, the reception station analyze and process the received data, remote sensing data. And the seventh step is the use of this processed data into the desired applications such as classification. Remote sensing image structure. The structure of remote sensing images is similar to digital image structure. For one band remote sensing image structure or grayscale digital image, it can be represented by two-dimensional array. The multi-band remote sensing image structure is the same as digital image structure, color image structure, but in remote sensing image, there are more than 3 bands that depends on the remote sensing source. Where the digital image structure have 3 bands, for as an example, for RGB image, we can see 3 band red, green, and blue, but in remote sensing, it can be more than 3 bands. Okay, each strides has own numbers of bands and its band indication depending on the sensor type and spectrum. The remote sensing image has 3 types of resolution. The image resolution, digital resolution, such as digital image resolution, it depends on the number of pixels in the image and the bit depth. The spectral resolution, that depends on the sensor's wavelengths and spectrals, and the spatial resolutions, which is the area that's covered by 1 pixel. Now we talk about the reviewed algorithms in this paper. The reviewed algorithms in this paper are the minimum distance classifier, the parallel pipe classifier, the maximum likelihood classifier, the decision tree classifier, the support vector machine or SVM classifier, the artificial neural networks or ANNs classifiers, and the object-based image classification. The minimum distance classifier is based on the Euclidean distance. The pixels that are located in the shortest distance to a specific class are classified to this class. The parallel pipe classifier is based on creating decision boundaries between sample classes. These decision boundaries are created by utilizing the abstraction results for mean and standard deviation values. The maximum likelihood classifier is based on calculating the probability of the given pixel to the pixels in each sample class. The given pixel is classified to a certain class when it has the maximum probability to this class. The decision tree classifier. It's based on building a tree structure that contains 3 types of node: leaf nodes, internal nodes, and one root node. Okay? It doesn't need training, but it requires complicated calculations. The structure of this tree is determined by self-intuition, and it's very difficult. It's the difficulty of this type of classifiers. It has a good computational efficiency. The support vector machine or SVM classifier is based on establishing optimal hyperplanes from the training data. These hyperplanes separate the different classes by building the margins between classes. Maximizing these margins between classes on both sides of hyperplanes is the target for achieving the optimal SVM classifier. The artificial neural networks or ANNs. It's based on the structure of biological neural networks. The definition of this classifier is algorithms that try to mimic the human brains. The ANNs are formed of a sequence of layers. Each layer contains a set of neurons. The input layer is the output layer, is the first layer, and the output layer is the last layer. The internal layers are hidden layer. Each neuron are fully connected with other neurons and preceding and succeeding layers. These connections are called weights. The accuracy and performance of ANNs based on the structure and hyperparameter values. It's have a high rate. This ANN have a high rate and needs more time for training, and also needs sophisticated hardware for training. it can act as pixel-based or object-based image classification. It's a base of deep learning techniques. The object-based image classifier is based on data that consists of groups of homogeneous pixels called features or objects. The image objects represents the similar pixel groups that share the same spectral properties such as shape, texture, color. The key component of the object-based image classification is segmentation. Segmentation is a procedure of grouping image pixels into portions or objects, which are called segments. These grouped pixels must share a homogeneous spectral similarity. The accuracy assessment and the comparative topics. The accuracy assessment. This paper presents four methods for assess the accuracy for the learning models and remote sensing images. The producer accuracy, the user accuracy, the kappa coefficient, and the overall accuracy. The producer accuracy and the user accuracies. The producer accuracy is the accuracy from the point of view of the producer of the map. The map producer or the map maker can give calculate the accuracy with his point of view. It's based on the reference pixels in that particular class. However, the user accuracy is the accuracy from the point of view of the map user. So it's based on the classified pixel of that particular class. The kappa coefficient, it's an old accuracy assessment from 1964. It's based on the number of true positive predictions or false positive predictions and false negative predictions and true negative predictions, but not widely used now. But it was widely used for many years, but not now. The overall accuracy or OA is the main widely used now for assessment the accuracy of learning models. It's based on the number of correctly classified pixels and the total number of checked pixels. Now the second aim of this paper is the comparatives between some surveyed papers for using of machine learning algorithms for classifying remote sensing images. The comparative topics of this layer of these papers: three papers published in 2017, five papers published in 2018, two papers published in 2019. These papers are chosen from many of papers that published for the same topics. The comparative results. These results are taken from the surveyed papers. The object-based image classification have the higher accuracy assessment accuracy for each paper that have compare object-based and pixel-based image classification. The SCVM and the ANNs, the SCVM is greater for some papers, and ANNs is greater in the other papers. But we see in MAIOL the accuracy of object-based image classification is less than the accuracy of SCVM and ANN in BAS-AOL. That means that the dataset type and the research environment can affect on the overall accuracy for the learning model. The previous slide shows the overall accuracy for comparing the surveyed papers. In this slide, we show we see the kappa coefficient for comparing the surveyed paper results, and it gives same results of this comparison. The conclusions. The classifier accuracy was depend on some conditions such as the classifier method, the imagery spatial resolution, the remote sensing image source such as satellite or UAV, the image produced here, the feature selection, and the image class such as land use, land cover, trees, forests. The minimum distance classifier is based on the Euclidean distance. The pixels that are located in the shortest distance to a specific class are classified to this class. Thanks for your attendance. Questions.